Okay, so as in the last video we have discussed about the matter and its classification. In today's video we are going to discuss about the discovery of subatomic particles, right? So here we have atomic structure. So structure means basically location or position or placement of particles in the space, right? So let me write this here. Structure means location, position or placement of particles that too in the space, right? That too in the space, that too in the space. Now we have more than 100 subatomic particles, right? We have more than 100, more than 100 subatomic particles, and among these 100 subatomic particles we have three particles. Those are fundamental, or you can say basic particles, right? Let me write that here. Among these 100 subatomic particles we have three particles. Those are fundamental, or you can say basic particles or subatomic particles, right? And those are electron, proton and neutron. Let me write this here. Those are electron, proton and neutron. Electron, proton and neutron, right? Initially we said electron, we have considered it as a wood particle since it is lighter than all. Then proton, we consider proton as a concrete particle, and we consider neutron as a iron particle since it was heavier than both of these particles. That's why we consider neutron as iron particle, right? These are three fundamental or basic particles of the atom, right? So today we are going to discuss the discovery of subatomic particle, and we are going to discuss the discovery of very first subatomic particle, which is electron, right? Electron was discovered by J.J. Thomson. Let me write this here. Electron was discovered by J.J. Thomson. J.J. Thomson, right? Electron was discovered by J.J. Thomson. Let me highlight this. It was discovered by J.J. Thomson. And which experiment did he do for discovering the electron, right? He did electrolysis. So the name of the experiment was electrolysis. Let me write this here. Experiment was electrolysis. And what is electrolysis? Let me tell you that. Electrolysis is basically a passing current through a very low pressure of gas in the discharge tube. It is passing of a current through a very low pressure of gas in the discharge tube, right? It is basically a passing of a current through very low pressure of a gas in the discharge tube. So this is the experiment he did for discovering the electron, right? Let me highlight this too. This was the experiment. Now what instrument did he use to discover the electron? He used discharge tube, or it is also known as Gasler tube, or we can say it is Crookes tube, right? So the instrument which he used, was either discharge tube, because it has alternative names, right? Discharge tube, it is also known as Crookes tube, or you can say it is Gasler tube. Right? It is Gasler tube. Now what things did he use to discover the electron, right? Let's see this here. Now this is the picture of the discovery of electron. This is basically the discharge tube, which you can see here. This is the discharge tube. Now what things did he use? He used cathode ray, as you can see. This is the cathode. This is cathode, which is negatively charged plate, right, in the discharge tube. Otherwise, in the galvanic cell, the anode and the cathode particles charge changes, but here the cathode has negative charge. It is the negative charge plate, right? It is the negative charge plate. Then we have anode, right? In the right hand side we have anode, and that is positively charged plate. This is anode, and this is basically positively charged plate. This is positively charged plate, right? So cathode has negative charge and a negatively charged plate, and anode has positive charge, which means it is positively charged plate, right? Inside the discharge tube we have filled the gas, right? There is a gas, and this gas is helium gas, right? Helium gas. I'll tell you why we have used here helium gas, because it has some properties, and I'm going to tell you those properties too. Why did they use helium gas, right? So this is basically what? This is helium gas. This is helium gas inside the discharge tube, and they have put one vacuum pump as well, since they want to decrease the pressure, right? This is the vacuum pump. This is vacuum pump, and they have connected this discharge tube with a very high voltage source, right? With very high voltage source, and this pressure is from 5,000 to 10,000 volt, right? So this is basically the pressure from the 5,000 to the 10,000 volt. Now what did they do? At the ordinary temperature, right? At the ordinary temperature there was no conduction. For example, they gave the ordinary temperature, so there was ordinary pressure, so there was no any conduction. But when they reduced the pressure of the gas, this was basically ordinary pressure of the gas, right? Here was ordinary. So here it was in conduction, all right? But when they reduced this pressure of the gas, the whole discharge tube got lighted with the green color, right? With the green color got lighted. But when they reduce the temperature more, and they reduce the temperature till 10 power minus 4 Armstrong, or you can say it was 0.01. They reduce the temperature, then there was not glow, right? There was not glow. Only there was glow on the end of the plate, right? There was glow on the end of the plate, for example here, Here it was glow since it was covered, this whole discharge tube was covered with zinc sulfide, the fluorescence material, fluorescent, right? So here it was glow, here it was glow since it was covered by zinc sulfide and it is the fluorescent material, fluorescent material, right? So when this what, the coming ray or the coming particle hit to the surface of this plate, here it was like perforated anode, so here it was passing through this since it was perforated, right? So here there were particles hitting to this plate and this plate got glow. Then we got to know that here we have some particles which are coming from the cathode ray, and going towards the anode, and they are going towards the anode. In the result, the plate in the end in the right hand side is glowing, right? So there we got to know that, as since those particles were coming from the cathode and they were going to the anode, means there are some particles which are attracting towards the positive charge, and the charges which attract towards the positive charge are negatively charged particles. So we got to know that there are some rays which are originated from the cathode, so means those are cathode rays, and cathode rays are manufactured by the negative charge particles which are cathode particle, right? Since they were attracting towards the positive, and we know that negative charge attracts towards the positive. So we got to know that there are cathode rays which are manufactured by the cathode particle, and those are negatively charged particles which are going towards the anode positive charge particle, right? And the charge, like the cathode particle, was named by Stone as electron. So Stone was the scientist, was the scientist he named cathode particle or cathode ray, cathode particle as an electron, right? So this was the discovery of electron in the discharge tube, in the gasser tube, or you can say in the cruise tube. In the next video we are going to discuss the properties of the cathode particle.